Hello dear students. In today's video we are going to discuss the first chapter of chemistry, chemical reactions and equations. So in lower class we already discussed about different types of chemical reactions and chemical changes that are happening in our day-to-day life. See, when you take food, the food gets digested in your stomach, and similarly, uh, you can see the fruits ripens, and similarly, if you keep some amount of milk in an open vessel, so after some time it will turn to curd. So similarly, there are a lot of chemical reactions or chemical changes that are happening in our world. Can see similarly rusting of iron. These are all examples of chemical reaction. So in this chapter we will be discussing about chemical reactions and equations, how we represent a certain chemical reaction with the help of an equation. See, let us discuss about what is a chemical change. Chemical change. So last year we might have studied about two type of changes. One is chemical change, another is physical change. These two are the two changes associated with the matter. So physical change means what? Change in the state, in from solid to liquid or liquid to gas. So similarly, change in certain other properties such as rigidity, compressibility. These are, so when we discuss about a chemical change, so during a chemical change, what is happening? Suppose you take iron, for example, iron nail. If you keep it outside for some days, what will happen? So it will turn its color to brownish red color. So some coating you will be able to see. So that coating is known as what? Rust. So here what is happening? Oh, the case. So take the case of example of milk. So if you keep milk on a hot day for a long duration, say for a morning to evening, so what will happen? So after by the evening, it will change its taste. So it will become sour, and thereby it will change to curd. So the milk and curd, these are two products. They are chemically different. So during a chemical change, what is happening? Suppose simple example, if you burn a piece of paper, so can you get the paper back? You cannot. So similarly, so suppose once the milk turns into curd, you cannot turn the curd back to milk again. So such chemical changes, these are irreversible once the fruits gets ripened. So what happens? You cannot get back the unripe fruit. Similarly, once the iron gets rust, so you cannot turn back the rust into iron. So these are all the processes or the properties of chemical change. These are irreversible changes. These are irreversible changes, and one substance loses its identity once it turns into a new substance. So for example, we have seen in the last video when we burnt magnesium ribbon. So when you take magnesium ribbon and clean its surface in order to remove the magnesium oxide layer. So with a sandpaper, so magnesium ribbon, when you heat, as you heat, what happens? So it will combine with the oxygen present in the atmosphere, so as to give magnesium oxide. So this is a chemical change, just like a burning of paper, burning of a candle. So these are examples for digestion of food, cooking of food. If you make chapati, you can't make the wheat, get the wheat flour back again. So these are all what happening during a chemical change. So but during physical change, what are those happenings? So once, uh, suppose say solid, ice in solid state gets converted into liquid state. Here the matter remains the same. Water remains water itself. Only its state is getting changed. Such kind of changes, this process is reversible also. We can, if you cool the liquid, you can get converted back to solid again. So this kind of changes, physical changes, these are reversible, but chemical changes are irreversible in nature. So you can represent a chemical reaction with the help of a word equation. So here the scenario what we observed there, magnesium ribbon when it is burnt, so it will react with oxygen to form a white color magnesium oxide. Let the observation. As a result, you will obtain a white color powder. So this magnesium oxide so formed, so it's a different substance. When it combines with magnesium, say magnesium for example, it's a metal, it's a highly reactive metal. So normally when it is kept in open air, so at that time also magnesium reacts with oxygen so as to form magnesium oxide. And when you heat this magnesium ribbon, a clean magnesium ribbon, what happens? The magnesium combines with oxygen so as to form magnesium oxide. It is that will result in the production of a white color powder. This observation is important, and while burning it will produce dazzling white flame. So this is the word equation for this particular chemical reaction. So every chemical reaction you can express in the form of word equation. So using the name of the elements and the products of form as such. So here you can see the magnesium. So this is coming in the left hand side. So here magnesium as well as oxygen. So these two are the chemicals that are taking part in this chemical reaction. See here what is happening, magnesium combines or unites with oxygen. Magnesium combines with oxygen so as to form magnesium oxide. So what are the reactants or the substances which are combining so as to give a new product? So these are called reactants. So which is written towards the left hand side of an equation. So if more than one elements or compounds are there, so you will separate it with the help of a plus sign. Here magnesium reacts with oxygen so as to give magnesium oxide. So there is no other products formed, so that's why we are not adding any more plus there. So these two combines, magnesium combines with oxygen, so that's why we are adding here a plus sign. So these two are the substances which are taking part in the chemical reaction. The substances which are taking part in a chemical reaction are known as reactants. And the substances formed as a result of chemical reaction, the substances which are formed as a result of a chemical reaction, representation of a chemical reaction in the form of the name of the substances which have already taken part in the reaction, and so on, so the substance produced during the chemical reaction. So this type of expression, that is known as word equation. So it is somewhat lengthy. Word equation is somewhat lengthy. So instead of that, we know last year we studied about what is the symbol for magnesium, Mg. The symbol for oxygen is O2. So oxygen normally exists in the form of molecule. That means two oxygen atoms combines together to form O2 molecule. So that's why we are writing oxygen as O2. So as a result, magnesium oxide, the formula of magnesium oxide is MgO. That's why we are already studied magnesium. The valency of magnesium is plus 2 and valency of oxygen is minus 2. So when you cross over the valencies of these two elements, so normally plus 2 will cancel with minus 2. So result you will get MgO. The product so formed is magnesium oxide. Magnesium oxide, it is represented by the symbol, using symbols, the chemical formula. Chemical formula of the compound, that is MgO. M should be capital letter, G small letter, and oxygen capital letter. So when you look at this particular equation, chemical equation, so one more law regarding chemical reactions that we studied last year. That is the law of conservation of mass. The law of conservation of mass. So which states that mass of the reactants during a chemical reaction, the mass of the reactants will be equal to the mass of the products, or the total mass of the reactants, that will be equal to the total mass of the products. So during a chemical reaction, or it can be stated in other way, the total mass remains conserved during a chemical reaction. So nothing is lost, nothing is gained. So here, when magnesium reacts with oxygen, it forms magnesium oxide. So, but as you count, look at here. Here Mg, the symbol Mg represents only a single magnesium atom. O2 represents two atoms of oxygen. So as we look at towards the right hand side, this is the right hand side of the equation, RHS. So MgO, magnesium oxide. Here one atom of magnesium is there and only a single atom of oxygen. So is it balanced? No. So such type of equation is known as skeletal equation. Skeletal equation is the unbalanced equation which is used only to represent the chemical reactions in terms of its symbols, or which are the chemical reactants, or the reactants which have taken part in the chemical equation, or the products which have been taken part in the chemical reaction. Just we are representing using the symbols and chemical formulas of the compounds so formed. So such an equation is known as skeletal equation. Skeletal equation. Remember the formula. So it needs not to be balanced. And similarly, so what can we do in order to obey the law of conservation of mass? In order to obey the law of conservation of mass, mass can neither be created nor be destroyed during a chemical reaction. Or what means the total mass of the reactants. The total mass of the reactants must be equal to total mass of the products. So here you can see magnesium. We can write it as it is left hand side. In order to, now we are discussing about the balancing of chemical equation. So in order to balance this particular chemical equation, we need to write down both left hand side as well as the right hand side. Then what are the reactants? Just we mention the names of reactants towards left hand side. Magnesium. How many atoms of magnesium are there? Only single atom, one. So we represent one. Oxygen. On reactant side, there are two atoms. That's why we write here 2. So towards the right hand side, when you look at the right hand side, the element Mg, magnesium atom is here only 1. So we write here magnesium atom 1, and outside oxygen. Oxygen atom is also 1. So now let us look here, 2 atoms of oxygen. So there we cannot change anything to the substrate. In order to make here O2, here we can't change, here we can't write O2 here. What's the reason? If you write, it is not possible, because in order to obey the valency, the law of valency, so in order to satisfy the valency of these 2 atoms, so we need to write the formula of magnesium oxide as it is. Magnesium oxide, MgO. Here we can't change the subscripts, but we can change the what is the coefficients. The coefficients we can change. So now let us look. So in order to make the oxygen atoms 2, we can add it 2 over here towards as a stoichiometric coefficient towards the left hand side of the chemical formula of that particular compound. Here only we are able to make changes only on this side, or here or here. So while you add 2 here, 2, it becomes 2MgO. Clear? So as you look towards the left hand side, now the 2 atoms of oxygen as well as 2 atoms of magnesium is over there on the right hand side. And when you look at the left hand side, what happens? here already two atoms of oxygen is there, but in the earlier case there was only one oxygen atom. So in order to make that magnesium 2, we are writing here. So now you look at the two here. On the left hand side there are two atoms of magnesium, as well as on the right hand side there are also two atoms of magnesium. So their mass is balanced. And similarly you can see oxygen. Here two atoms of oxygen, and on the right hand side also there are two atoms of oxygen. This 2 is common for both magnesium and oxygen. This 2 is applicable to magnesium and oxygen. So the number now gets balanced. So such an equation is known as balanced chemical equation.